Okay, so this is unit 1 of this video lesson, so let's get started because I have only 5 minutes. So the first thing you learn is scalars and vectors. Scalars are quantities, vectors are quantities with magnitude. As you can see, vectors are velocity, acceleration, and displacement. Scalars are speed prime. I don't think there's a word for that in scalars. And distance traveled. Yes, and these vectors in question can be written in vector notation / arrows. So as you can hear, I provided 2 examples. These are arrows and these are vector notations. So you can calculate these vectors based on what shape they are. V1 equals AI plus BJ, V2 equals CI plus DJ, and you add it just like kind of, you already know how to do this. It's like algebra. And by arrows, you can just put the other arrow on where the initial arrow left off. So that's pretty easy. Delta x equals x minus x0, that's displacement, that's change in position, and x0 is the initial position, so it shows a change. And doing stuff with displacement and time is basically kinematics. It's all you're going to learn in this unit. So velocity is displacement over dt, means infinitesimal time, and acceleration is displacement over dt squared. So it's basically taking the derivative of the velocity. It's like dividing it with time once again. And I wrote this nifty little equation, not equation, just relationship, in here. And it's basically calculus, if you have taken calculus already. Yes. So Vx equals V0 plus AXT. It's basically the relationship between velocity and constant acceleration. So as you can see, AX is a constant. And if you just integrate that, you get the next equation where x equals x0 plus v0t plus 1 over 2 at squared. So displacement in constant acceleration, you just integrated it. And the other one is just, it's kind of complicated to show it, and it's pretty nice in certain problems. It's useful in weird problems. So I would advise you to kind of memorize it. And this is just the graphical and calculus related version of this relationship. So yeah. So let's move on to reference frames. Reference frames in physics, it's like very important because everything in physics, we kind of have the premise that it's relative. So velocity, when I look at something and when I look at something from some other direction or like place, it's going to look different. So VAB, velocity of A when B is looking, is equal to VA minus VB. So basically velocity of A for a stationary object minus velocity of B for a stationary object. Now the stationary object in question is also kind of charged. It's hard to define, but in questions usually they will tell you what is stationary and they will tell you the stationary velocity. Stationary velocity as in like what velocity an object has in the perspective of the stationary thing. Anyways, it's getting too long. VAB minus VBC is VAC. So you can find relative velocity like implicitly, as I have written here. You don't have to know the VA and VC to know VAC. And this is just an example. It's just try it. Just look at it and you're going to be able to understand it. Just try it yourself. I really highly advise you that. And the last part is the equations part. And these are the equations that you're going to use like practically. And to be honest, these two are like, these three actually, these three are like the only things you're going to use. The other parts are pretty preliminary. Not preliminary, that's the wrong word. It's frivolous. Yeah. So that was unit 1.